This is the data collector singleton. Right here, make sure that you can't make a copy of it because that's the point of a singleton. Right here, get instance returns the one instance of the singleton that exists. Add entity adds an entity to the list of entities whose data we are tracking. Update updates the distance, total distance traveled by all entities. This is called every single time the simulation model updates. Update package is called when a package is delivered. That updates increments the amount of packages that have been delivered. Same for update collisions, except for collisions avoided. Print data prints the data to a formatted CSV file. Add observer, remove observer, notify observer, this is observer stuff. P-instance is the single instance of the singleton. Mutex is the mutex for thread safety. This is the way that I'm storing the entities and their data. We have the entity by ID and also a pointer to the entity. The ID is because of duplication for some reason was a problem. And entity pointer so that I can access fields like the current position and whatnot. Float is the total distance traveled. Int and int is the number of packages delivered and the number of collisions avoided respectively, and vector 3 is the last position of said entity. This is observer stuff. Up in here we get instance, we add an entity, we do updating. This takes the current position, subtracts it from the last position, you get the absolute value of that, and you increment the total distance traveled by that. Update package, update collisions, that is same thing, does the thing. Print data, prints it to a CSV, aggressive basis specifics. Say if we do this, speed it up, deliver the package gets dropped off, delivered, and we hit print data, and then it notifies and it logs the data. That was over here, hit print data, and it does it. See. Stop simulation, stops the simulation, and then it also prints the data. CSV file looks like that. That's what the data looks like. That's how it's stored. There you go.
All right, so this is my final for 3081. So I created a new airplane entity, which inherits from iEntity. Its movement is pretty much the same as helicopter. It just uses beeline strategy. And then this is its movement strategy, same as helicopter. So then it has this change course function, which just sets a random position that's 1,000 units away from the origin of the map on the XZ plane. So that's just a random, it'll randomly go to a random point that's 1,000 units away from the center when it reroutes. But it does spawn in 3,000 units away, which I'll show you in a second. And then again, it just uses the beeline strategy, sets a new one, just goes right to that point. Then its update function is pretty much the same as helicopter, except when the movement is over, it just calls change course, which is that same function up here. And then airplane factory, same thing as helicopter. And then air traffic control. Let's see, so this has a function called full distance, which just gets the distance between two vectors. Then it has this function called get future points, which takes in an entity and a number, and it gets back a few points ahead of where the entity will be in the future based on its path strategy. And the reason I implemented this one is because I wanted to see when they would collide in the future. I didn't just want to take the current distance between the two airplanes. And then that's so that I can therefore just have one of the planes reroute instead of having both of them, which I implemented in this function called will collide. So this one, it just takes in an airplane, then it loops through every other airplane in the sky, and then it calls the previous function of get future points, and it checks the distance between all of those points for both the airplanes, and if any of them are less than 50, it reroutes the first, just the first plane. So then there's reroute there. Then it adds flyer to the sky, so that's just you can loop through all of the airplanes that are currently in the sky. And then we have this decorator class, which just essentially calls all of those functions in airplane control for all of the airplanes, and it just keeps those as a wrapper. So here's what it kind of looks like. So there's this button up here, which I said I'll show you. When you click it, the airplanes randomly spawn in 3,000 units away from the origin, and you can click it as many times as you want and get as many in there. And then when you turn it up, they all go directly towards the center, but you notice that none of them will ever collide. And once they get going, they stay within 1,000 units away from the center, and they'll never hit each other.